Page 88, some more critiques. Top graph, they say, well, the bars are too wide and short, and the bottom graph, they're too tall and thin. Okay, that may be a matter of opinion, but I would tend to agree in this case. And so the authors are really critiquing quality of the presentation of data here. All right, well, if you look on page 90, this is called a scatter graph. And in this case, they took the same data. They took the age of the grooms being married versus the age of the brides being married. And each point on that graph represents a couple, a man and wife. Now, if you look at that scatter plot on page 90, you'll see that there's a trend. There's an upward trend from lower left to upper right. And so one purpose of doing a scatter graph is to reveal trends. Now this is when you're looking at two variables. And so anyway, if you look on there, you'll find someone about here. There's one that's kind of an outlier right here in the middle of the graph, but at the top, that top dot. What is that person? Well, that's a person who, it looks like a man who married a wife who's older than he is. Someone older than he is. That's rare. It's rare for men to marry a woman who's somewhat older. So it looks like the man was maybe 37 and the bride was about 46. Okay. So you can spot some differences there. There's another one here. A man who is 41 married a woman who's about 29. That's another kind of extreme. That shows up kind of down below here. All right, so anyway, you can spot some things by looking at these scatter graphs that are kind of interesting. Okay, now they do some other types of graphs, and I don't want to get too bogged down in this section either. There on page 95 is a map of the United States. It's kind of like the one I was referring to, except the one I was referring to was by county in the United States. This is just by states. And it shows the distribution of divorce rates in the United States per 1,000 people. So anyway, it's kind of interesting presentation of data. Let's see. Page 99 has a picture from USA Today, and USA Today, at least it used to be pretty famous for these kinds of graphs. This is an example of chart junk operating with higher pay. How much higher the average doctor's pay is than the average worker's pay in 4 countries. And they illustrate that with the size of the money bags that these doctors are slung over their shoulders. That's certainly an example of chart junk. It's an entertaining graph, but it's got too much junk in it to be a serious statistical graph. All right. Finally, let me see. I think we're down to this. My very favorite graph. And really, there's something serious about this, too, that I can bring up. If you look on page 112, and recall this is kind of an old book. It was printed in 1997. The top of the page has silhouettes of secretaries of defense from 1973 through 1989. Starts with James Schlesinger, who was 6'4". Donald Rumsfeld, 5'10". Harold Brown, 6 foot. Caspar Weinberger, Frank Carlucci. Look at John Tower, 5'5". So, what is the point of this graph? It looks like these guys are really getting shorter, isn't it? Look at the trend. These guys are getting shorter. Poor Tower is only about half the height of this fella. At least it looks like it in the graph. So, my gosh, the Secretaries of Defense are shrinking. They're going down to nothing. To me, I think it's about the funniest graph I've ever seen. But there is something serious about it, a serious point to be made. is that it's distorts. And I wonder if you can, because a guy who's 5'5" is not half as tall as someone who's 6'4". So what explains this? You know, what explains the distortion in this graph? And give you a second to think about that. The distortion is not a distortion of the scale. The distortion is the fact that they don't show these guys down to their feet. Because if you line them against the wall, John Tower would not be half as tall. Oh, sorry, telephone. Let me answer that. I'll be right back. Sorry for the interruption. I was talking about the distortion in this graph. The distortion is the fact that they don't show these guys from head to toe. And because if you line them up against the wall, Tower would not be half as tall as Schlesinger. And so this is an example of lying with statistics. The classic example, lying with statistics. And the explanation is that in order to not distort a chart or a bar graph or something like that, you've got to start it at 0. In other words, the scale has to start down here at 0 and show everything. When you don't start at 0, if you start somewhere up above here, then these differences in heights get exaggerated, and that distorts the picture. And so this is a device that's been occasionally used out there, say in advertising, for example. You can distort the looks of the data by not starting at 0 on the vertical axis, starting up above, and so those differences get exaggerated. So anyway, that's a good example of lying with statistics. Of course, I think they did this graph tongue-in-cheek, the publication that put it out. But anyway, that's I like that example. All right, well, that's about all I have to say about Chapter 3. And it's time to get down to business in Chapter 4. In Chapter 4, I'm going to move to my regular room where I video these, where I have a board, and we'll start doing some computations. So for that, bring out your calculator and work along with me. So I'll see you in Chapter 4.